JNTech Networks is a highly reputed best networking training institute in India. We are one of the most preferable Cisco certification training institute. We offer candidates to learn from the industry's best networking engineers, network specialists, and network experts who have more than 12 years of industry experience. We offer courses like New CCNA 200 to 301 CCNP Enterprise Infrastructure, CCNP Security, CCIE Enterprise Infrastructure, and CCIE Security V6. Multi-vendor technology courses including checkpoint certifications, AWS certification, Palo Alto Firewall, ASA, Cisco Firepower Firewall, F5 Load Balancer, BGP, MPLS, Fortinet Firewall, Cyber Security, CEH, Wireshark, and CompTIA Security Plus.
Let's start our discussion now. Juvency?
Yes, we can start. I'm ready.
Okay, so our last topic was, I think, route summarization, I think.
Yes.
So we complete our RIP and EIGRP summarization, right?
Yes.
Okay, now let's focus on protocols now, okay? And today we are trying to start our OSPF protocol first. Let's start our discussion with OSPF, and this protocol will take minimum 5 to 6 sessions. Juvency, okay?
Okay, no problem.
So our first dynamic routing protocol is OSPF, Open Shortest Path First. It's a full form of OSPF protocol. Let's talk about some feature. Let's talk about some feature about OSPF protocol. So OSPF is a link state routing protocol. OSPF is a link state routing protocol. If you talk about RIP protocol, RIP is Open Standard Protocol. OSPF is also an open standard protocol. OSPF is a link state routing protocol, but RIP is called distance vector routing protocol. Distance vector. What is distance vector means? Any idea what is distance vector? What is distance vector routing protocol? For example, I have R1 router and R2 router. If I'm using any distance vector routing protocol in between R1 and R2, for example, RIP protocol I'm using. So the problem with the distance vector routing protocol is they send routing updates. They will send update after every 30 seconds. Okay. They will not send incremental update. I'm talking about distance vector routing protocol, RIP. They will not send incremental update. They will always send periodically update. For example, R1 will share his routing table information with R2. Now, after 30 seconds, again, R1 is sharing his routing information with R2. Again, after 30 seconds, R1 is sharing his routing table information with R2. This is the problem. This is the problem with the distance vector routing protocol. They send routing update periodically. But if you talk about OSPF protocol, OSPF is a link state routing protocol. It means it always send incremental updates. Whenever any change happen, then one router will share his update to another router. Clear my point? So OSPF is a
Yes.
state routing protocol. It's a open standard protocol, so we can use on any vendor like Cisco, Juniper, Alcatel, any vendor. OSPF is using SPF algorithm, shortest path first, or DJ Castra algorithm. If you talk about RIP protocol, if you remember from CCNA training, RIP is using Bellman-Ford algorithm, right?
Yes.
RIP is using what? Bellman-Ford algorithm to find the best route. Bellman-Ford. If you talk about EIGRP protocol, EIGRP is using dual algorithm. Dual algorithm to find the best route. What is dual algorithm? Diffusion update algorithm. RIP using Bellman-Ford, but OSPF is using SPF algorithm, shortest path first, or you can say DJ Castra algorithm. It's a classless routing protocol. OSPF is a classless routing protocol. EIGRP is also a classless routing protocol. RIP version 2 is also classless routing protocol. What is classless means? It support FLSM, VLSM, CIDR. So it support FLSM, VLSM, and CIDR, and it support manual summarization only. If you remember
Okay.
summarization
Yeah.
concept, remember root
It's correct
summarization
about it.
concept. RIP and EIGRP, they do auto summarization, but in
Auto summarizer.
you need manual summation. You can say, right?
Yes. Yes. I
Now,
remember.
yes, let's talk about other points. So OSPF sends incremental updates. Incremental update means what? Whenever change happen, then R1, for example, we have R1 router and R2 router. Now, OSPF send incremental updates always. For example, R1 will exchange his routing table information with R2. Now, when there is a change, for example, one network here down, one network is down, or one network is up. Whenever any change happen, then R1 will update this information to R2. So it sends always incremental update, not periodically update. Now, hello timer, OSP of hello timer is 10 second. So after every 10 second, R1 will send a hello packet information to R2. Only hello packet, not routing information, hello packet. You can say keep alive message. R1 is sending hello packet to R2. R2 is sending hello packet to R1. And hello packet timer is what? 10 seconds. So after every 10 seconds, they are exchanging hello packet information. Now, what is dead interval? What is dead interval? So for example, R1 is not available. R1 is down, for example. And R2 is not receiving any hello packet. So one hello packet timer is what? UNC.
10
seconds. So if one
Yes.
first hello packet is miss, okay, first hello packet is not coming from R1 because R1 is not available. So now R2 will wait. In this case, R2 will wait for 3 hello packet more. It will wait for 3 hello packet. One hello packet timer is 10 seconds. 3 hello
10
packet
seconds.
timer is what? 30 seconds. So
30 seconds.
first hello packet is miss. Now R2 will wait for 30 hello packets. So total it will wait for 40 seconds.
40.
In 40 seconds, if R1 available, if R1 is available, good. If R1 is not available, then R2 will remove or flush R1 information from his routing table. R2 will flush the route information about R1 from his routing table. Now in new routing table, R2 don't have R1 route information. So now in next hello packet, R2 is sending route information to R3. And in new updates, R1 information is not available. Clear my point? So dead interval is what? 40 seconds. OSPF updates are sent as a multicast address. And OSPF is using two multicast address 224.0.0.5, 224.0.0.6. So OSPF is using two multicast address. If you talk about a RIP protocol, RIP is using one multicast address. If you talk about EIGRP is using multicast address. RIP EIGRP is using 224.0.0.10.10 and RIP is using what? 224.0.0.9. And so RIP and EIGRP, they use single multicast address. But OSPF is using two multicast address, 224.0.0.5, 224.0.0.6. So where you can use 224.0.0.5 and where we can use .6, we'll discuss, okay? But right now I'm giving you an idea. We have two multicast address in OSPF protocol. Get my point? You can see.
Okay. Yeah.
OSPF metric calculation. OSPF works with bandwidth. EIGRP works with bandwidth. OSPF works with bandwidth. High bandwidth, least cost. Least cost, best route. OSPF administrative distance is 110. If you talk about static routing AD value, 1. RIP AD value, 120. EIGRP AD value, 90. OSPF AD value is 110. Now OSPF, see, OSPF, RIP protocol, EIGRP protocol, and OSPF protocol, they support equal cost load balancing technique. They support equal cost load balancing. What is equal cost load balancing? For example, I have a R1 router, R2 router, R3 router, R4 router. Now, if I'm using, for example, RIP protocol, so RIP always works with hop count. RIP can't understand bandwidth. RIP always works with hop count. So if here is a source, and this side we have a destination. So from this source to this destination to reach, from this source to this destination, we have two routes. You can go via R2 or you can go via, so you have two routes. Now you can see via R2. Via R2, you have two hop count, 1 and 2. You have two hop count. And via R3, you have two hop count. So to reach this particular destination, you have multiple routes. You have multiple routes with same hop count, with same metric. So what router will do? R1 will install both the routes in routing table, and it will utilize both the routes. Clear my point? You can see. This is
Yes.
called equal cost load balancing. To reach
Cost
any
root.
yes, you can see.
You say cost root balancing, right?
Yes. To reach any destination, if you have multiple routes with same metric, then router will install all the routes into the routing table, and it will always do load balancing. And what it's called equal cost load balancing. So RIP, EIGRP, OSPF protocol, they support equal cost load balancing. But if you talk about EIGRP protocol, so EIGRP can support equal cost load balancing and unequal cost load balancing. Yes, in EIGRP, we have a great feature. Unequal cost load balancing. So equal cost load balancing and unequal, both options we can use in EIGRP protocol. But if you talk about RIP protocol, RIP, OSPF, EIGRP, they only support RIP or OSPF, they only support equal cost load balancing. Clear now this point?
Okay.
Now, OSPF is using area concept. Remember from CCNA training? OSPF is using what? Area concept. You can put all your devices in OSPF area. Let me tell you. Let me create a design first. Okay. So in OSPF, we have area concept. All the routers we can put in an area. Okay. These are routers. Okay. Not desktop machine. These are routers. Now, in OSPF, we have area concept. We have area concept, and here we can create area 0 first. In OSPF, what we have area concept. So you can create area here. You can put all your devices in area. What is area, Juvency? What is area? Remember from CCNA training, it's a logical grouping of routers, right?
Yes.
It's a logical grouping of routers. So in OSPF, we can create area here. And as per rule, as per default concept, you will create area 0 first. Wait. Area 0 first. Okay, so this is R1, this is R2, this is R3, R4. So as per rule, you need to create area 0 first. So what I'm doing, I'm trying to put all the devices. You need to create area 0 first. Why area 0? Because area 0 is called backbone area, right? Area 0 is called what? Backbone area, or you can say transit
Backbone.
area. You can say transit area. So what I'm doing, I'm trying to put all the devices in a single area. Okay, I'm not creating multiple area here. Yes, you can create multiple area. So, but first you need to create area 0 first, because area 0 is mandatory. Area 0 is called backbone area or transit area. So what I'm doing as a network admin, I'm trying to put all my devices in area 0. If I'm putting all my devices in a single area, in area 0, for example, I have I have 200 routers, and I'm putting all the devices, all the routers in a single area, area 0. Now, what will happen if I'm putting all the devices in a single area? So if anything happen into this area, for example, network goes down, for example, this router is not working, this network goes down. If anything happen into this area, it will disturb all the routers. This update will disturb all the routers within an area. And now into this design, I'm not using high-end routers. All the routers are not high-end routers. No. Into this design, I have some access layer router. You can say entry-level routers. I have some mid-range kind of routers. I have high-end appliance. I'm not using all the devices are not high-end appliance. Okay. Into this design, I have some entry-level routers. I have some mid-range routers. I have some high-end appliance. So entry-level routers, they have limited resources, hardware resources. If I'm putting all my devices in a single area, so this update will disturb to all the routers. High-end routers will receive these updates. They can handle no problem. But what about entry-level route? They have limited buffer size. They have limited hardware resources. So maybe they cannot maintain these updates. Clear my point?
Yes.
So that's why we are not putting, my point is, we are not putting all the devices in a single area. No, that's why. That's why we are not putting all the devices in a single area. What we can do, we can create multiple area here. We can create multiple area, but the rule is you need to create area 0 first. So what I'm doing, I'm trying to create area 0. So these routers I'm putting in area 0. So first you need to
Yeah.
create area 0.
Okay.
Now second, if you are creating other areas, for example, I'm creating area 20. These routers I'm putting in an area 20. So yes, you can create multiple area, no problem. You can create multiple area. For example, this is area 30. This is area 40. Yes, you can create multiple area, but the rule is all the area must be directly connected with the area 0. You can see.
Okay.
So I'm creating multiple area, 10, 20, 30, for example, 20, 30, 40 area. But you can see into this design, all the area are directly connected. They are directly connected with the area 0. See,
Yeah.
area
Okay.
20 is connected with area 0. Area 30 is connected with the area 0. Area 40 is connected with the area 0. And this
Okay.
router, this R2, wait, this R2, this R3, and R4. These routers are called ABR router in OSPF. These are called ABR router, area border route. Area border route. R2, R3, R4, they are called area border router. Why? Because his one interface is a part of area 0, and other interfaces, they are the part of any other area. So this router is called what? ABR, area border
Yeah.
router. This area border router can send area 20 updates to area 0, area 0 update to area 20. Now same, we have R3. R3 is an ABR router. R3 is an ABR router, area border router, because his one interface is a part of area 0 and other interface is a part of area 30. Now R4 is a part of area 0. So R4 is a part of area 0 and other interfaces are the part of other areas. So this router is called what? ABR. So in OSPF, we have ABR router concept, area border router. We have one more type of router in OSPF concept. This is called ASBR router. We have one more type of router. It's called ASBR, Autonomous System Border Router. What is ASBR router? So ASBR router, ASBR router, one interface is a part of any other routing protocol. For example, this interface you are advertising in RIP protocol, or maybe EIGRP protocol, or maybe BGP protocol. So this router one interface is a part of any other routing protocol, and one interface is a part of any area, area
Any
0, 20, 30, 40, 50, any area. So this router is called ASPR router, Autonomous System Border Router. Clear my point? Clear this point?
that is clear.
Okay. Now let's talk about within the area now. You will see. Let's talk about within the area. So I'm talking about this area, for example, area 30. Same concept you can use, same story you can use for area 20, area 0, area 40, or for any area. Let's talk about in area. So into this area 30, one router will act as a DR router. This is called DR router, and here we have BDR router. So in every area, we have two type of routers: DR router, designated router, and BDR, backup designated router. For example, within an area, if you have 50 routers, for example, 50 routers, So one router will act as a DR, one router. One router will act as a BDR, backup designated router, and rest 48 routers, they are acting as a DR other router. They are called what? DR other. Clear my point?
Yeah.
So into this area, one router will elect as a wait. One router will elect as a DR and one router will elect as a BDR, and rest routers are called DR other. DR other. Now, what is the benefit of DR and BDR in every area? In every area, we have DR BDR concept. What is the benefit of DR and BDR in every area? So now this time, if anything happen into this area, any network down or new network introduced, if anything happen into this area, they will send the update only to DR router. They will send update only to DR router. They will only disturb to DR router. This update will not disturb to each router within an area. If you have DR router in your area, then if anything happen, all the update will only disturb to DR router, like commander router. Clear my point?
Yes.
Any update will send to the DR router. Now DR will send this update to the rest of the router. For example, some network is down here. This update will send to the DR, and now DR will send this update to the each router. So this is the benefit
Okay.
of DR. Anything happen into this area, they will not disturb to any other router. No. They will send update only to DR. Now then DR will send this update to the rest of the routers. I hope this point is clear for you. You can see.
Yeah, it's clear. That means the gear should be connected to ABR
ABR
or
router.
not. Yeah. The
See,
gear router
ABR router.
should be
Yes, ABR router is a part of area 30 and ABR router is a part of area 0. You can use your
ABR, yes.
ABR router as a DR, no problem. You can use any router as a DR.
Oh, okay.
See,
Okay.
ABR is a separate concept. DR, BDR is a separate concept. What is ABR means? This router is a ABR. Why? Because his one interface is a part of area 0 and other interfaces, they are the part of any other area. These type of routers are called ABR router, area border router. Clear my point?
Yes.
Now I'm talking about within an area. I'm talking about within an area. Now within an area, we have two type of routers, DR and BDR, designated router and backup designated router. Here the benefit of DR and BDR in an area. What is the benefit of DR and BDR in an area? Juvency? What is the benefit?
Sorry, come again.
What is the benefit of DR BDR in an area? I told you. What is the benefit? If anything happen,
For DR,
huh?
yes, yes. For DR, if anything happen in the area, all routers part of that area
They will send
will send
update to the
message
DR router only, right?
to the DR.
Then
Yes,
DR will send this update to the rest of the router. I hope this point is clear.
yes, it's clear.
Now let's talk about DR BDR election process. DR BDR election process within an area.
But
How they will
sorry,
decide?
what about BDR? What
It's a backup.
rule?
It's just a backup.
The backup. Okay,
Yes,
backup.
just
In
a
the
backup.
case of DR is not available.
Yes, DR
They will
goes
send.
down, then BDR will elect as a DR router. Okay, BDR will elect as a DR. Clear now?
Clear.
It's just a backup router.
Okay.
Now let's talk about DR-BDR election process. Okay, within an area, how they will decide. They will decide which router will act as a DR or which one will act as a BDR. How they will decide? DR-BDR, DR-BDR. So here we have priority value. Here we have priority value concept. All OSPF router or Cisco router has a OSPF priority. All Cisco router has a OSPF priority value, and the default priority value is 1 for all Cisco router. Default OSPF priority value is 1. And a router is having higher priority value will become DR router. For example, on this router, I'm using priority value 150. Yes, we can change. Default is 1, but we can change. We can change in between 0 to 255. Okay, so here we have 150. Here, for example, we have 140. So this router is acting as a DR. This router is acting as a BDR. And the rest router is called what? DR other.
Other.
What? DR other.
I don't get this point very well.
Okay,
This
no
is
problem.
this is
No problem. I'm telling you
from
again, no
0
problem.
to from 0 to 255 is the priority, right? You are talking about
Priority value
priority
is from 0 to 255. Default is
okay.
default is
1.
for all Cisco router. OSPF priority value is 1. Okay.
1. Okay.
And a router is having higher priority value. Higher priority value will become DR router. Higher priority
Okay.
value will become DR router. So for example, on this router, I'm using 150 priority value. So this router is what? DR.
DR.
Okay, here we have 140. So this router is what? BDR.
BDR.
Backup designated router. And rest of the routers, they are called DR other. Okay, DR other.
Yes.
These routers are called what? DR other. Clear now this point?
Yes.
How they
Clear.
will decide? How they will decide DR and BDR election? Okay, now let's do a basic lab. Okay, for OSPF DR BDR election. Okay, give me 1 minute. I'm creating a design. I want to show you DR and BDR election process. Wait. So these routers I'm using in an area 0. I'm using in an area 0. I'm trying to advertise in area 0. IP address I'm using 192.168.10.1/24. This one is 10.2/24. Here we have 10.3/24, 10.4/24. Now let's configure IP address. Let's configure IP address here. So this is R1. Let me give a host name so that you can identify we are working with R1. As per design, I'm trying to configure IP address. Hear my point? You can see
Yes.
192.168, 10.1, 255, 255, no shutdown.
0.
No shutdown. Let's go to R2 router. host name R2, interface gigabit Ethernet 0/0 192.168.10.2 mask, no shutdown. R3, interface gigabit Ethernet 0/0 192.168.10.3 mask, no shutdown. Router OSPF process ID 192.168.10.0. I'm not using OSPF protocol right now. Let's configure IP address only. Let's go to R4. R4, and I'm trying to configure IP address on here. So host name R4, interface gigabit Ethernet 0/0 192.168.10.4 mask, no shutdown. Now router OSPF process ID network 192.168.10.0 wildcard mask area 0. Let's advertise all the routers in OSPF 192.168.10.0 wildcard mask area 0. Let's go to this router. Router OSPF process ID network 192.168.10.0 wildcard mask area 0. So I'm trying to advertise all the devices, all the routers in OSPF area 0. 10.0 wildcard mask area 0. Any problem in root advertisement? UNC?
No, it's okay. It's okay.
Okay, now. So let's go here. Let's go for verification. Show IP OSPF neighbor. Please wait. It's taking time. Now you can type show IP OSPF neighbor command. Let's see to verify DR and PDR information. So you can see we are here, right? You can see this is R1 router.
Yes.
We
Yes.
are here. So this is R1. This is R2, R3, and R4. So you can see as per our output, show IP OSPF neighbor. As per our output, 10.4 neighbor status is what?
Yeah. Ah, okay.
10.3 is what?
BDR.
And 10.2 is what? DR other.
BDR other. The
Now
other.
you can see, you can verify priority value here. Now you can verify priority value here. Here we have default priority value on each router.
Yes.
Default priority value on each router, and default priority value is 1, right?
1, yeah.
Value is 1. So if there is a tie, in between priority value, the tie breaker is higher router ID. Remember in OSPF, we have router ID concept. Router ID, if you forget, no problem, we will discuss, okay? Router ID. But here we have higher router ID. Higher router ID on R4, 10.4. That's why this router by default, this router is acting as a DR. Clear my point?
Yeah. Yeah.
Our discussion right now is on priority concept. So here we have right now this R4 is a DR, this one is a PDR, this one is DR other, and this R1 is also a DR other. Now, in case if I want to use R1 as a DR,
Okay.
if you go and verify on R4, for example, show IP OSPF neighbor. So you can see R1 is what? DR other. R2 is what? DR other. R3 is what? BDR, right?
BDR.
In case,
Yes.
if I want to use R1 as a DR, R2 as a BDR, then we need to change priority value here. Okay. We need to change priority value here. Let's go to R1 router and how to change priority value. So you can go to interface. You can go to interface gigabit Ethernet 0/0. And what is command? IP OSPF priority value. IP OSPF priority value. And if you type question mark, you can see you can select a number in between 0 to 255.
255.
So I'm using, for example, I'm using 150, 150, 150, and now I'm trying to restart OSPF process. So command you can use clear IP OSPF process. Yes. I will press enter later. Okay. Let's go to R2 first. You can go to interface, IP OSPF, priority value. And a priority value I'm using what? 120. Here I'm using 150 and here I'm using 120.
120.
Now, clear IP OSPF process. I'm not restarting this router. I'm trying to restart only OSPF process. Now let's go to R3. Clear IP OSPF process. Let's go to R4. Clear IP OSPF process. Okay, let's start. Okay, now wait. Wait, they will take time. Now, as per our task, we are using 150 priority value here. 150 priority value here we are using 120 priority value. So now if you verify again this time, on R4, router this time, so you can see show IP OSPF name. So as per our theoretical portion, on R1 we have higher priority value. So this router is what now?
Yeah.
And R2 on R2 we have priority value 120. So status is what? BDR.
BDR. Okay.
Clear this point? DR, BDR election process.
Very clear.
Now, let's go to this design. Let's go to this design. Okay. Now, into this area, for example, one router is a DR, one router is a BDR, right?
BDR. Yes.
BDR. Now you can, for example, into this design, you have, for example, these two routers. These two routers are low-end router, for example. Into this area, you have some low-end routers, you have some mid-range router, you have some high-end appliance within an area. For example, these two routers, for example, this is R5 and R6. These two routers are low-end router. For example, you have CISCO 1841 series of routers. Entry-level routers, for example. You have limited hardware resources here in R5 and R6. And you don't want to, for example, R5 and R6, they have limited hardware resources. Limited hardware resources. So if you want, whenever negotiation happen for DR and BDR, whenever negotiation happen for DR and BDR election, these two routers, they will not participate in DR and BDR election process. Clear my point?
Yes, because of limitation of resource.
Yes, they have limited hardware. Okay, they cannot handle too much load.
Yeah.
They cannot handle too much load. So that's why I don't want to use R5 and R6 to become DR and BDR? No. Okay, because when DR goes down, BDR will become DR and the next router will become BDR.
Yeah. Okay.
So my point is what, whenever negotiation happen, I don't want to use R5 and R6 as a DR or
DR
BDR
and B.
process.
Mm.
Okay, so you can verify here. You can verify into this design. For example, let's go to R2, or let's go, sorry, gigabit Ethernet. Okay, let's go with the R4. Okay, no problem. R4. So interface gigabit Ethernet 0/0. IP OSPF priorities. Now clear IP OSPF. I'm using default priority value on each router. Okay, let's go with the default priority value again. 0/0 IP OSPF priority value 1. Clear IP OSPF priority. I'm using default priority value on each router. Show IP OSPF priority 1. Clear IP OSPF process. Clear IP OSPF. Now, so I'm using default priority value on each router. So if there is a tie, if you remember, if there is a tie, a router is having higher router ID will become DR. Remember our
Yes.
previous task when we have same priority value on each router. Then this R4 on R4 we have higher router ID, so R4 become DR. Remember our discussion?
Yes.
We are using up now. This time we are using same priority value. Here we have priority value 1, priority value 1, priority value 1, but on R4 we have priority value 0. So this R4 will not participate in DR BDR election.
Okay.
Yes, let's verify. Show IP OSPF neighbor. You can see R4. R2 is a wait. We change priority value on R2. Okay, it's a different interface. Wait, give me 2 minutes. Okay, let's go to R1 now. And we can start our verification. Please wait. This will take time. Show IP OSPF neighbor. So you can see now we have same priority value on each router. But R4 is not a DR. Why? R4 is what? Why? Because we have priority value.
It's 0. It's lower.
This route will not participate. This router will not participate in DR BDR election process. Clear this theoretical portion in practical?
Yes, it's very clear.
Okay, Juvency. Now
Yes,
let's
it's clear.
continue this point. Let's continue this point tomorrow. Okay, same time.
Yes.
Clear? Bye. Take care.
Thank you. I have one concern. I didn't receive the video of last session,
Okay.
last two session.
I'm sharing both the recording 30 minutes, okay?
Yes, and also I have one issue with my Genius tree. I don't know. I lost everything. Event router. I'm not showing my router. Can I share the screen and
Yes, sure.
can check? 2 minutes.
You can share your screen.
Nice.
You can share your screen now.
Okay. Because I did also some practice. Where is this? Where is this Genius tree? Is already open. I can share all my screen. Okay. This one is Zoom. Let's go to. Okay. Here, this one is the VMware.
Yes, now you can
The
start
problem is,
GS3.
yeah, it started from here.
Yeah.
You
Can
see, when I come here, no router.
Can you please allow remote control request?
Okay.
What IP subnet you are using? Can you cancel this? Can you cancel this? Okay, wait. Close this application. Let's go to, can you open VMware workstation now? You can see.
Yeah, it's open.
VMware workstation, yes. Right click on GNS3, right click on lab. Right click. Go to setting.
Setting.
Yes.
Okay. Okay.
Wait. VMware 1, VMware 8. It's good. Click on cancel. Okay, 192.168.59. Okay. Start your GNS3 software again. Wait.
Because I did some lab of static root, and when I find this one was not working, I download the packet tracer, and I did it. Okay, can wait. Okay.
Now please allow remote control request. Okay, wait. It's not showing here. LAN card is not showing. You can power off your GNS3, okay? Restart
Okay.
your laptop and enable and disable both the LAN cards. Can you click on cancel?
Okay.
Can you click on close this application?
Yeah. Yes.
Yes. Now, can you open? Wait, let me do this. So I think you don't have IP address on LAN card. Okay, see. You are getting IP address from Apipa. So what is the troubleshooting? You can just go to LAN card setting ncpa.cpl whenever you face this issue, ncpa.cpl. you can disable and enable both the LAN cards. Just disable, okay? Disable and enable.
Okay.
Whenever you face this issue. Now it will work, okay? You can close this GNS3, VMware GNS3 software. Close this and you can start again. Now it will solve, okay? You can try to and see.
Okay.
Now, restart your
Yes.
power off first, VMware workstation, GNS3 VMware workstation. Or
I need to power off my computer, right?
can you minimize this? Can you minimize this?
The CMD.
Minimize this command prompt. And wait. See. Click on OK. Click on OK. Now it will work. Can you click on router? Can you see? Let's continue tomorrow.
It's okay.
Okay.
Thank you.
Bye. Take care.
Thank you.
Okay, our last topic was OSPF implementation. Remember? OSPF
Yes.
implementation. Okay. And we complete our OSPF basic lab. OSPF basic lab. If you remember the concept of OSPF, we can create area 0 first. Area 0 is called backbone area, or you can say transit area. If you are creating multiple areas, then all the areas must be directly connected with the area 0. This is the concept, right? You will see.
Yes.
Now let's use a different topology today. And into this design, we have one area. And this area is not directly connected with the area 0. Let me create a design. So into this design, we have multiple areas. Okay, we have area 0. This portion we are using as an area 0. Now we have area 10. Area 10. Area 20. Let's define IP address configuration first. So here I'm using 10.1.12.0/24. Okay, this one is a part of area 0.
Look back.
Now we have area 10. 10.1.23.0/24. Now we have 10.1.34.0/24. And this one we are using in area 20. Now for routes, let's create some loopback interface. So 1.1.1.1/32.192.168 10.1/24. So I'm creating two loopback interface on R1 router. Okay, let's go to R3, and I'm creating two loopback interface here, 3.3.3 and 192.168.30.1/24. And these loopbacks
Okay.
I will advertise. these loopbacks I will advertise into area 10. Now we can create loopback on R4. So 4.4.4.4/24 and 192.168 40.1/24. So we have loopback interface here. Now let's try to configure IP address on routers, and we can advertise our network in Ospf area as per our design. UNC. Clear my point?
Yes. Yeah.
Let's try to advertise our routers in Ospf area as per design. So we have R1, R3, R4. Okay, let's access R2. So into this design, I'm trying to configure IP address configuration. We can start our configuration with R1 router. Let's start our configuration with R1. Show config the interface fast Ethernet 0/0 10.1.12.1 mask. No shutdown. Interface loopback interface 1.1.1/32. We can create loopback 192.168 10.1 mask/24. Show IP interface brief. Let's advertise our network in Ospf area. So router Ospf process ID 10.1.12.0. As per design, we are trying to advertise into area 0. Now 1.1.1 loopback into area 0. 192.168 10.0 into area 0. Let's go to
Yes.
R2.
Alto.
Fast Ethernet 0/0 10.1.12.2 mask no shutdown 0/1 10.1.23.1.
1.
Now no shutdown. Now we have two interfaces. Show IP interface brief. Now router Ospf process ID 10.1.12.0. 12.0. Areas
Area
10.
area 10.
Yes, you will see. Any question?
Yeah. No, you're right. On that area, on that IP, we are on area 0. Yeah.
Sorry, can you repeat your question
Good.
again?
No, I say for that the IP 10.1 10.12.0 is on
Yes,
area 0.
it's a
That
part of
means
it.
this one, yeah, this one will carry to area
23 is a part of area 10.
10. Yeah.
Okay, yes. And advertise these networks, this network into area 0, this network into
Right.
area 10. Okay.
10.
Let's
Yeah.
go to R3 router. And on R3, we have two physical interface and two loopback interfaces, 0/1, 10.1.23. Mask, no shutdown. Now 0/0 interface, 10.1.34.1 mask, no shutdown. Show IP interface brief. Now we can create loopback interface. Interface loopback 0, 3.3.3.3 mask. Interface loopback 192.168 30.1 mask. Now show IP interface brief. Let's advertise our network. Router Ospf process ID 10.1.23.0 wildcard mask area 10. Yes, area 10. Now network 10.1.34.0 wildcard mask area 20.
Area 20.
Now Now 3.3.3.3 wildcard mask area 10. I'm trying to advertise in area 10, both the loopback interfaces. Now 192.168 30.0 network into area 10. Now let's go to R4. R4 fast Ethernet 0/0 10.1.32.2. No shutdown. Interface loopback 0. 4.4.4.4 mask. Interface loopback 1 192.168.40.1. Show IP interface brief. Let's advertise our network router Ospf process ID 10.1.34.0 wildcard mask area 20. And yes, we have some loopback interface 4.4.4.4 into area 20 192.168.40.0 network. And I'm trying to advertise into area. Any problem in IP address configuration or root advertisement?
No.
Simple task, right?
No problem.
It's a simple.
Very simple.
Now, let's start our verification. If you remember OSPF concept, in OSPF protocol, we can create area. What is area? Logical grouping of routers. So we can create area and we need to create area 0 first. Why? Because area 0 is called backbone area. It's a transient area. And if you are creating multiple areas in your design, you are creating multiple area, then all the area must be directly connected with the area 0. This is the rule, right? This is the rule.
Yes.
So now into this design, if I'm trying to verify route information here, show IP route OSPF. If I'm trying to verify route information right now, so yes, I'm receiving some route. I'm receiving some route from R3. See, 3.3.3 back, 192.168.30 network, 10.1.23 network. And yes, area 10 is directly connected with the area 0, right?
Yes.
R2 is acting as a ABR router.
ABR, yes.
Area ABR router, area border router in between area 0 and area 10, right?
Yeah.
But I'm not receiving any route information from R4. I'm not receiving any route information from area 20. See, I'm not receiving 4.4.4.4 loopback, 192.168.40 network. No, I'm not receiving. If you go and check on R4, for example, if you go and check on R4, show IP route OSPF, so you can see you are not receiving any route information. Check show IP OSPF neighbor. Yes, you have a neighbor relationship. You have a neighbor relationship with R3, but you are not receiving any route information. Why? Because area 20 is not directly connected with the area 0. Okay.
Yeah.
So what we can do into this design? What is the solution? What is a possible solution we can do? Because I'm working in a design where I have some areas, and these areas are not directly connected with the areas. So what is the possible solution? Let's go with the slide. What is the possible solution we have for this problem? Wait. Okay. So now what is the possible solution? First solution, we can extend area. This is the first solution. What? We can extend area. It means what we can do, no need to create area 20. Hear my point? No need to create area 20. You can extend your area 10. You can extend your area.
Okay.
But
Okay.
if you are extending your area 10, then if you are extending your area 10, then
You need to change
in area you
configuration
have a
from
lots
browser.
of routers, right?
Yes.
And they will maintain equal database.
Hmm.
Okay, this is the problem. Now. First solution is what? Extend area 20. And I cannot extend, for example, because I have some lower series of router, I have some high-end router. Okay, and if I'm trying to extend my area, all the routers will maintain equal database. I have some low-end router,
Hmm.
cannot maintain a big routing table database. That's why I cannot extend. Okay.
Hmm.
Now,
Hmm.
next solution, connect physical link. Connect a physical link from area 0. What is the next solution? Next solution is, wait. Now, what is the next solution? Connect a physical link. Connect a physical link with area 0. And maybe it's
Mhm.
not possible in your design, okay?
Yeah.
Area 20 is a part of any other branch and area 0 is a part of any other branch. And it's not possible to connect a physical cable, physical link. Then what is the next
Hmm.
solution? The next solution is our topic today. And this is called configure virtual link. So you need to configure virtual link.
Okay.
This is our topic. Topic is what? OSPF virtual
Virtually.
link concept. So what we can do in virtual OSPF virtual link? So we can logically trying to extend our area 0 logically, okay, not physically, okay. We are trying to extend
Hmm.
our area 0 logically to R3. And if R3 is a part of area 0 logically, it means area 20 is directly connected with the area 0.
Yes. Yeah.
So what we can do into this design, wait. So what we can do into this design, we can create a virtual link. For virtual link, what you can do? For virtual link, what you can do? Identify the virtual area first. Identify the virtual area first. And which one is a virtual area? So in between, in our design, in between area 30 to area 0, we have this area, area 10.
Hmm.
So area 10 is what? Our virtual area. Clear my point?
Our virtual link is 10, right?
Area 10 is what? Our virtual area, because in between area 20 to area 0, we have one area here, right?
They pass through.
So
Yeah.
this area will act as a virtual area. Now, when you get your
Vir
virtual area, when you get your
Mhm.
virtual area, what is the next task? Next task, try to identify border routers. Border.
Or
So this is our virtual area, area.
yeah.
And yes, we have border routers here. R2 is a area border router. R3 is a area
Okay.
border router. So we have two border router here. So first step, try to identify your virtual area. Next step, once you find your virtual
The
area, try to find border
the
router
border
in virtual area. So we
router.
have R2 and R3. And what is the
Mm.
next step? What is the next step? Exchange router ID. Exchange router ID with area virtual link command. Exchange router ID.
Mhm.
Exchange router ID information with virtual link command. So what I'm doing, let's go to R2 first. And if I'm trying to verify router ID information, so command is show IP protocol. This is router ID. UNC. Clear my point?
Okay. Yeah.
R2 router ID. Now, if you go and check R3 router ID, show IP protocol. So yes, 192.168.30.1. This highest loopback interface is acting as a
Yes. The
router.
highest look back.
Yes. So now this one is a router R2 router ID. This one is a R3 router ID. We need to exchange the router ID information with each other with virtual link command. Now,
Okay.
now we can exchange, no problem. We can exchange router ID with virtual link, no problem. But the point is here we have router ID, and you can see why this IP address is acting as a router ID 10.1.23.1 because this interface is having highest physical interface IP. That's why this one elect as a router ID for R2, right? You can see,
Yes.
right? So here, see,
Yes, it's right.
the problem is if problem is what? Once you exchange router ID information with both the routers with virtual link command, no problem, you can do this. But the point is, after 1 month, after 2 months, administrator create here a new loopback interface, for example. And this
Yes.
loopback interface is, for example, 5.5.5.5. Once you create
The
your loop
highest one.
interface, so remember, router ID, once
Yes.
if you have loopback interface, then router will not go with the physical interface IP, right?
Physical interface. Yes.
So after 1 month, after 2 months, if any administrator will create a loopback interface here, then router ID will change here. And once router ID
Then you
change,
will lost it.
then yes, you will lost your virtual link.
Mm.
You will lost your virtual link. That's why into this scenario, you need to go with the manual router ID. You will see.
Okay.
For virtual link topic, you need to go with the manual router ID. So what we can do, we can go with the protocol router OSPF process ID. And what is the command to configure manual router ID? Router ID is a command.
Mm.
Router ID. So I'm giving router ID, for example, 22.22.22.22. Once you press enter, you can see you are getting a message. Try to reload your router or use clear IP OSPF process command. So I'm not restarting this router. Okay, I'm using what? Clear IP OSPF process.
Process.
Let's go to R3. And I'm trying to configure router ID manually. So router ID, for example,
Okay.
33.33.33.33. Now clear IP OSPF process. Clear IP OSPF process. Now let's verify router ID this time. Show IP protocol. So 33.33.33.33. Show IP protocol. You can see 22.22.22.22. Now we can
Yes.
exchange router ID information with
Hmm.
virtual link command. So what you can do, you can go to router 2 and what is command? Area. So
Mm.
which area you want to use as a virtual area right now into this design? Area 10, right?
Yes.
Area 10. So I'm using what? Area 10. Now question mark. Here is a command. What?
Virtual link.
Virtual link. So virtual link. And what is R3 router ID? 33.33.33.33. Let's go to
Okay.
R3 router OSPF process ID area 10 virtual link. And what is virtual link? What is router ID of R2?
22.
22.22.22.20.
22.
Done. Done your configuration. And if you go and check,
Okay.
on R1, for example, this time R1, show IP route OSP, you can see Now I'm trying to verify on R1. I'm trying to verify on R4. Show IP route OSPF. So on R1, this time, yes, I'm receiving route information from R4C.
Yeah.
You can see clear my point.
Yeah, very clear.
Now, if you go and check on R4 this time you are receiving all the routes. All the routes from R1, R2. So logically, we extend this area 0. We extend this area 0 to here. Now please help me, Juvency. Please
Yeah.
help me in case, if I have one more router here. Okay. One more router. And this R4 is connected with R5 and this one is a part of, for example, area 30.
That was my question. Yeah, so I was preparing to ask this question. If we
No
have
problem.
more area
No
in
problem.
the middle.
Now in case if I have one more area here, okay, 10.1.45.0, and now it's the area 30. Now what we can do, because area 30 is not directly connected with the area 0, okay, right? So
Yeah.
let's go here R4 first. Okay, wait. Let's go with the R4. So I'm trying to configure IP address first on R4 router.
R4.
Interface fast Ethernet 0/, and you will help me in 45.1. Let me configure IP address, and I'm trying to advertise network 10.1.10.1.45.0 area 30. Let's go to R5. Now 0/1. Now 10.1.45.1. Mask. No shutdown. Show IP interface. Show IP interface brief. Router OSPF process ID 10.1.45.0. Let's advertise in area 30. Now show IP OSPF neighbor. I'm not receiving any information. Show IP route OSPF. I'm not receiving any information. I think let me check is 0/. So
You
we
can
can get neighbor information.
you can add the loopback.
Yes, we can create loopback, no problem. Interface loopback 0. 5.5.5.5.5 mask, and this loopback I can advertise. I can advertise in OSPF protocol 5.5.5 area 30. Now I have a neighbor table. If you check, I have a neighbor table information, but I'm not receiving any route information from R1, R2, R3, and R4. So now please help me for this solution. What we can do now? Area 30.
Okay.
Area 30 is not directly connected with the area 0, right?
Yes.
And we logically extend right now. We logically extend our area 0 here. I think. Remember, it is
Yes.
already extended. Now what we
Yes,
can
already.
you can say it's a logically area 0. This portion. So in between
Yeah.
area 0 and area 30, which one is a virtual area?
Yes.
Area.
Exactly. That's why I was thinking. We need you need to create the virtual link between R3 and R4.
Yes. See, yes, you can. What you can do, you can. Here we have loopback, and here we have router ID 33.33.33,
Yes.
right?
Yeah.
And on R4, yes, we can configure router ID manually. So let's go to
Oh, yes.
R4
Yeah.
router
Okay.
ID, for example, 44.44.44,
Yes.
clear IP OSPF
Process.
process. Now we can verify, show IP protocol, and yes, router ID change. So now this one is a virtual area. And if this one is a virtual area, so R4 and R3, these two routers are what? These two routers are
Border.
right?
Border router. Yeah.
We can exchange router ID information with
Yeah.
virtual link command. Okay, so let's go to router OSPF process ID. Command is area. And what is virtual area name? Area 20, right?
20. Yeah.
Virtual
Virtually.
link. So I'm on R4, 3.33.33.33.33. Let's go to
Yeah.
R3 now. And on R3, we can go to OSPF protocol, area 10, virtual link, 44.44.44.44. Done. You can verify now. You can verify now here on both the routers. Let's go to R5 now. R5. And here I can check my routing table. Before check my routing table, let's go to R1 first. And on R1, this time I am receiving, wait, it's taking time. I'm waiting for 5.5.5 back. I'm not receiving. Please wait. Something mismatch here. Let me check. 10.1.32.34.
I think it's the area for R3. You set to area 10, the link, virtual link.
Let me check. 30. Virtual link not.
Someone,
Wait. Show IP protocol. 33 router ID here. Okay. So run pipe section OSPF. So let's check configuration first. So on
the
our
virtual link
we
should
have
be area 20.
okay. This is the mistake. Okay, area 10.
Yeah.
This is the mistake. Thank you. Router OSPF 5. No. So now we can change area 20.
20.
Area 20.
Yes.
Now we are getting a message loading to full, and we can check now on R5. Show IP route OSPF. Okay, I'm not receiving. Please wait. Yes, I'm receiving now. See,
Now you can listen. Yeah.
R5 loopback interface on R1. On R1 router. And if you go and check on R5, show IP route OSPF. So you can see you are receiving complete information. This is our topic, virtual link. Clear now?
Very clear.
Okay. Let's go to slide now. Wait. Give me 2 minutes. So we complete our OSPF area concept, multi-area design. Area must be a backbone area. Get this one area, it's complete. Root summarization is complete. Virtual link. Okay, now virtual link. Okay, now let's talk about UNC OSPF network type. So in OSPF, we have network type here. We have first one is called point-to-point. Second one is called what? BMA network, or you can say broadcast multi-access. NBMA, it's an old technology, okay? So no one using NBMA network type. Frame relay, ATM, X.25, these are old technology, okay? So you will not get these options. You will get only these two options here. This is called point-to-point. It means you are connecting your devices with serial link, UNC. You
Yeah.
are connecting your devices with serial link. But nowadays, we are using Ethernet technology. We are
Yes.
using Ethernet technology to connect LAN portion, WAN portion. Ethernet is a popular option. So whenever
Mm.
you are connecting Ethernet technology, whenever you are connecting your devices with Ethernet technology, this is called BMA network, broadcast multi-access network. Let me show you. Let me tell you this point. So what is broadcast multi-access network? In broadcast multi-access network type, it's like a LAN technology, okay? You can connect your devices with Ethernet technology. And into this network type, DR, BDR election are required.
Required.
Required,
Okay.
yes. This is what example of this is the example of broadcast multi-access network. DR, BDR elections or selection are required. And OSPF detect this type of link automatically, you will see. Automatically.
Yeah.
No need to tell anything. Okay, let me show you. Let me show you this option. For example, into this design, I'm using Ethernet technology. So if you go on R1, for example, and if you type show IP OSPF interface, fast Ethernet 0/1. This one is a great command for OSPF. Show IP OSPF. It's a great command. And you can you can go with the interface name. Why this command is a great? Because this command can give you a lots of output, a lots
Mm.
of information you can verify with this show IP OSPF command. Let me show you. So this command can show you the interface. See, fast Ethernet 0/0 is up, line protocol is up. What is IP address? And this IP address is advertised in area 0. What is process ID? What is router ID? Okay, what is network type?
Okay.
What is network type?
Broadcast.
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 Automatically. Link automatically detect. It's a broadcast, BMA network technology, Ethernet technology. If you are connecting, for example, if you are connecting your devices, with serial port, for example, let's connect with the serial interface. So I told you link automatically detect this devices, okay? So we are using serial port in between R6 and R7. I'm trying to configure IP address. We can advertise these routers in OSPF area. Let's go with R6. So as per design, interface serial 1/0, 10.1.67.1, mask, no shutdown. I'm trying to advertise in OSPF, router OSPF process ID 10.1.67.0, wildcard mask, area 0. Let's go to this into this router, serial 1/0, 10.1.67.2, mask, no shutdown, router OSPF process ID 10.1.67.0, wildcard mask area. So you can verify now, show IP OSPF neighbor. This is point-to-point connection, you will see.
Okay.
Whenever you are connecting your devices with serial port, this is called point-to-point connection. And in point-to-point connection,
Okay.
in point-to-point network type, there is no DR and BDR selection process. No. If you check show IP OSP of neighbor, you have a state information only. You have state information only. You are not getting only any DR, BDR information. You see? You will see. Clear my point?
Yes, it's clear.
You can also verify on R6, show OSP of neighbor. You have only state information, but you're not getting
Yes.
a DR, BDR option here. Now, let's use show IP OSP of interface serial 1/0. So you can see now, I told you link OSP of detect this type of link automatically. So if you go and check here, if you go and check show IP OSP of interface serial 1/0,
Okay.
type is what?
Point to point.
Automatically.
Point to point. Yeah, okay.
Automatically it will detect. Now let's go to slide here. So we have two network type, point to point and broadcast multi-access. Now let's go with that. Okay, let's talk about relation. Let's talk about relation. So here we have some routers into this area. This one is acting as a DR. This one is acting as a PDR. This one is acting as a DR other. This one is acting as a DR other. DR other. Now, what is the relation? So DR BDR relation with DR other is a full. DR other relation with the DR BDR is full. And remember, one DR relation with other DR is only what?
Two-way.
Now, what about updates? So I told you in OSPF, the OSPF protocol uses two multicast address. RIP uses one multicast address. EIGRP uses one multicast address, but OSPF using two multicast address, 224.0.0.5 and 224.0.0.6. So when DR other will send up any update information to DR BDR, they will use multicast address 224.0.0.6. You will see. It means when this DR this DR is trying to exchange update information to DR, for example. Okay, so it will send update with this multicast address. Clear my point?
Okay.
4.0.0.6. And when this DR, my point is, when this DR will send this update to other DR router, DR to other DR routers, they will use multicast address 224.0.0.5. And you can verify this is not just a story, okay? You can verify here. Let me show you. Wait. You can verify here. Wait. So if I go to this R1 router, if I go to this, okay, let's capture this packet information. Packet information. Packet information. So here I'm trying to verify background process. So you can see R1 is sending update. This R1 is sending update to this multicast address. What? 224.0.0.5. You are getting only 224.0.0.5. You are not getting any update with 224.0.0.6 multicast address. You can see, right?
Yes.
Okay. Point is, you are only getting updates with this multicast address .5. Where is the dot 6? I'm not getting any .6 information. 224.0.0.6. So if you remember our theoretical portion, when DR other, my point is what? When DR other will send any update to DR, they will use this multicast address. So what I'm doing right now, I'm not getting any new update from any DR other router.
Mm.
Here into this design, what we have, show IP OSPF. We have only BDR and DR. There is no DR other. There is no DR other.
Okay.
Show IP OSPF. There is no DR other.
Mm.
Okay, so let's create a design. Give me 2 minutes. I want to show you this. This is not just a story. Okay.
Yeah. Okay.
Into this design, I am using one router as a DR, one router as a BDR, and one router as a DR other. So let's try to configure IP address here. R8, we can configure IP address into this design. Interface fast Ethernet 0/0 192.168.10.1 mask, no shutdown, router. Okay. Let's go to R9. One 192.168.10.2 mask, no shut, no shutdown. Let's go to R10. Interface fast Ethernet 0/0 192.168.10.3 mask, no shutdown. Now router Ospf process ID 192.168.10.0 wildcard mask, area 0. Let's go to R9 router Ospf process ID 192.168.10.0 wildcard mask, area 0. Let's go to R8 router Ospf 192.168.10.0 wildcard mask, area 0. UNC, can you hear me here?
Yes.
Okay, show, let's check here on R9, show IP OSPF neighbor. Please wait, okay? They are in two-way state. Wait.
Mm.
Next start. Next start. Now full. So you can see now into this design. Maybe it's taking time. Now you can see. Into this design, this router is a DR, right?
Yes.
Router is a DR
Okay.
because of higher router ID. This router is what? BDR. And this
Yeah.
R8 is what? DR other. You
Yeah,
can
buffer.
check now. No problem. You can go to R9. You can go to R9 and you can use a command show IP OSPF neighbor, and you can see R1 router. This one router. This router is acting as a DR other. Yes, DR other. This one is acting as a DR. Yes, DR. Now what I'm doing, if I'm trying to capture the packet for R8 route, let's try to capture the packet. And what I'm doing, I'm trying to create a loopback interface here. Let's create some loopback interface, loopback 0. For example, 8.8.8.8. So I'm creating a new loopback, new update. You can say router Ospf process ID 192.168. No, 8 loopback 8.8.8.8. Wildcard mask area 0. When I press enter, this is DR other, you can see, right?
Yes.
This is DR other. See,
Okay. Now he's sending information to DR router.
yeah. This is what R8 router sending update to this multicast status. Why? Because
Yes.
he has a new update, and this he's sending to DR router. You can click,
Mm.
you can open it. I hope it's clear for you. Okay, this is not just a story. You can verify.
No,
This is source IP, LSU update, 8.8.8.
okay.
Clear now?
Yes.
You can see this is our topic. Now let's continue this topic tomorrow. Okay, so what we complete? DR VDR election, virtual link, updates, network type. Now tomorrow we'll focus on OSP of LSA type and OSP of stub router. Okay, let's discuss tomorrow. Yes.
Okay.
Bye dear, take
Thank you.
care. Tomorrow same time, okay?
Yes.
Bye.
Thank you.
Bye dear. Bye, take care. Hi everyone, I'm really happy to announce that our YouTube family has now grown to 1 lakh subscribers. And this is not just a number, everyone. It is a reflection of your trust and dedication of your learning. Thank you so much.